Yeah, see how to get that fixed. So today we look at another type of integral, and these are integrals of the type.
I don't know if it's only my internet, but it seems like you are breaking up a bit.
Know what is happening because I have to use my tab, my laptop. I can't seem to project on it today or just now because I was using it this morning and now it looks like it's frozen. Let's see. Let me just see if I can fix it. Okay, finally it's going through. Okay, so let me leave the tab. Okay, I think now you should be able to see my screen. Just let me know if you can see it.
Just can see.
Okay, so I think this should be better. I don't know what happened there. So today we look at integrals that look like this. This is ax squared plus bx plus c dx. Okay, so we have integrated ones that just have the square root over here. We said you must complete the square and then you make the substitution depending on whether it's in the form u squared minus x, u squared plus x, or a squared, excuse me, minus u squared. Now, when you have a term here multiplying by your square root, what you want to do is you want to separate this, write it as a sum, where the first part is the derivative of what you have in under the square root, and then you can just use u substitution to integrate that, and then the second part will be a constant multiplying by your square root, and you can always take the square root and then integrate this one the way we have been doing it. So I'm looking at an example of how this goes. We have the integral of 3x minus 1 times the square root of x squared minus 2x plus 5 dx. So we said we want to break this 3x up so that one part will be the derivative of x squared minus 2x plus 5, and then the other part will be a constant. Okay, and the derivative of that will be 2x minus 2. Okay, so to do that, this 3x minus 3, we rewrite it as 3x minus 3 plus 2, then square root.
Where is the 3 coming from?
I have minus 1 here. I can write minus 1 like this because I want this number here and that one to be the same, so that when I introduce, so that it's easier for me to write the derivative. But we've done questions like this before. Anyway, this is x squared minus 2x plus 5 dx. So now it's not stable. Okay, then this first two terms here, because they both have a 3, I can always factor the 3 out. So remember, with the first part, I want to make it 2x minus 2 because that is the derivative of what I have under the square root. Okay, so I have this 3, then x minus 1, square root of x squared minus 2x plus 5. That's my first derivative. And then the second one is the integral of x squared minus 2x plus 5 dx. Okay, so this x minus 1, it's not exactly the derivative of this because I need a 2 here and a 2 there. So I can multiply by 2 there and then divide by a 2 outside. So I should integrate 3 over 2 and then 2x minus 2 square root x squared minus 2x plus 5 dx. That's the first one. So you can see this is the derivative of that one. So integrating this is very simple, straightforward. Then this one here, when we want to integrate it, we have to make the substitution. Before that, you must complete the square over here. So we have, I'm going to take this to the next page. So we have that one. And plus the integral of 2. Then, excuse me, we said what we have under the square root here, we should complete the square. We get x minus 1 squared. Then there's a minus 1, which we add to this 5, we get plus 4 dx. So integrating this one, this is what we were doing yesterday. Excuse me. Here you would say let u equal to x minus 1, then du is just equal to dx. So our integral is 3 over 2, the integral of 2x minus 2 square root of x squared minus 2x plus 5 dx plus, and take the 2 outside, integral of u squared plus 4 under the square root du. Okay, so this one we can integrate it straight away. This will become x squared minus 2x plus 5 to the power of half plus 1 because it's under a square root. So this one here, we have the 3 over 2 that is multiplying. So this 3 over 2 here. Then because we have a function and its derivative, integrating by substitution, we just say this, it's to the power of a half. then you add 1 to its power, so you'll have x squared minus 2x plus 5 to the power of 3 over 2, and then you divide by 3 over 2. Okay, and you can see that this one and that one will cancel, and if you were to work out the derivative of this, you see the 3 over 2 comes down, then this will be to the power of a half, then multiply by the derivative of this, you get 2x minus 2. Okay, so that is this integral. Then to integrate this one, so we'll say those two will cancel, then we just write it like that. Okay, so here we need to make a substitution. So when we have plus here, we need to use tan. So we will say u is equal to a. Our a is 2. So we have 2 tan theta. Then du is equal to 2 sec squared theta d theta. And then we proceed the way we have been doing so far. So this is equal to x squared minus 2x plus 5 to the power of 3 over 2. And then we make the substitution over here. So u squared will be 4 tan squared theta plus 4. Plus the integral of 4 tan squared theta plus 4 d theta, okay, not just d theta. Then dx or du here is 2 sec squared theta d theta. So times 2 sec squared theta d theta. Okay, so there's a lot of writing. Minus 2x plus 5, 3 over 2. And here we can see that 4 is a common factor, so we take out the 4, and then we'll have 4 times tan squared plus 1, which is 4 sec squared theta. And if you remove the brackets, this is the integral of 4 sec to the power of 3 of theta d theta. Okay, so the square root of 4 is 2. You multiply it with this 2, and then you have tan squared theta plus 1, which is sec squared theta. The square root is just sec theta. So that sec theta, you multiply it by this one, you get sec to the power of 3 of theta. Then here we have to use by parts. So just keep it here. So I'm using u again, but it's not the same u that we started with. So u is equal to, before that, okay, so this I must write it as tan squared theta plus 1 times sec theta d theta. So before I use by parts, this is x squared minus 2x plus 5 power 3 over 2, and then I have 4 sec theta plus 4 sec theta tan squared theta d theta. Okay, then this one here, we know how to integrate that. That will be 4 ln of sec theta tan theta. So this will be x squared minus 2x plus 5, 3 over 2, plus 4 ln of sec theta plus tan theta, and then 4 times the integral of sec theta tan squared theta d theta. And now here is when we use by parts. So we say u is equal to tan theta, du will be sec squared theta d theta. And then dv is equal to sec theta tan theta d theta, and then v is sec theta. Okay, so we are integrating this one over here. And you have to remember where we started over here. We started for sec squared theta. So it's a little bit confusing, or it might be because there's another term here, and what we have on the other side is, what is that? Well, this is what we have on the other side. So what you can do is you can look at them separately. So the integral of 4 sec squared theta is this term here, that term there, that one there, and whatever we'll get here, because you will end up with another sec squared, sec to the power of 3 of theta that you need to take to the other side, and then you'll have to divide by 2, because that's what we always do. So maybe it'll help if I write like this: the integral of 4 sec cubed theta d theta. Okay, so I'm just looking at this part here, and then we'll add this answer here because this we've already integrated. So we've done all this, and now we're here. We're saying that the answer is 4 ln of sec theta plus tan theta. This is 4 ln of sec theta plus tan theta. And then we have for the integral of sec theta tan squared theta, which we integrate by parts. So this last two terms are the derivative of 4 sec to the power of 3 of theta. So now we add u times v. So we have sec theta times tan theta. So there's a 4 there. It must multiply. So this 4 here must multiply u times v. Sec theta tan theta. And then we must subtract 4 times v du. So that's v times du. We get sec to the power of 3 of theta d theta. Okay, so the reason again I wrote it separately is because I want to see that on the other side we have the integral of 4 sec to the power of 3 of theta d theta, and then on the right hand side I also have integral 4 sec to the power of 3 of theta d theta, so that I can take this one to that side and then just make 4 sec to the power of 3 of theta d theta the subject of the formula. So this is 2 times 4 sec to the power of 3 of theta d theta, which is 4 ln of sec theta plus tan theta plus 4 sec theta tan theta, and then we divide by 2. So this means that 4 sec cubed theta d theta is equal to 2 ln of sec theta plus tan theta, and then 2 sec theta tan theta. Okay, so this integral here is what we were looking for over there, and then we just have to add this part over here. So the integral that we were trying to work out from the beginning was this one. And all we need to do is replace theta in terms of u and then in terms of x. So if you remember the substitution we made, we said that u is equal to x minus 1. Okay. U is equal to x minus 1, and also u is equal to 2 tan theta. So u is equal to x minus 1, and also u is equal to 2 tan theta. This means that tan theta is u over 2. So we draw our triangle, put theta here, and this is the opposite, this is the adjacent, this is u squared minus 4. So tan theta in terms of x, this is x minus 1 over 2, and then sec theta we know is the hypotenuse over the adjacent, and we can replace u or rewrite u in terms of x. So this is the square root of x minus 1 squared minus 4, and then divided by 2. So we'll substitute everything here, there, and there, and then come and substitute over here, and this and the integral over here in terms of x will be our final answer. So doing that, we have 2 times ln of sec theta. Okay, so sec theta we said is the square root of x minus 1 squared minus 4, the whole thing over 2, x minus 1 squared minus 4, the whole thing over 2, and then plus tan theta, which is x minus 1 over 2. And then we have 2 sec theta tan theta, so this is 2 times x minus 1 over 2, that's tan theta, and then sec theta. So you can see the 2's there will cancel, and there is supposed to be a constant. There is a constant there, and remember that this denominator here, because the denominators are the same, you can split up or rewrite this as the logarithm of the numerator minus the logarithm of the denominator, and the logarithm of the denominator is a constant which you can add to this constant here. So if we write it nicely, what we have is that the integral of 4 sec to the power of 3 of theta d theta, this is just equal to x minus 1 over 2 times the square root of x minus 1 squared minus 4 over 2. No over 2, because this 2 here is that one there, and then we have plus 2 ln of the square root x minus 1 squared minus 4. Notice the denominator 2 is gone because we've added it to that constant, plus x minus 1. Okay, then plus c. So this part here, like I said, is what goes over here. So our final answer, the entire derivative, which is the integral of 3x minus 1 times the square root of x squared minus 2x plus 5 dx. This is equal to, we said the first part, this one, is x squared minus 2x plus 5 to the power of 3 over 2. And then the second part, which is this entire expression. So it's x minus 1 over 2 times the square root of x minus 1 squared minus 4 plus 2 times ln of the square root of x minus 1 squared minus 4 plus x minus 1 plus your constant of integration. Okay, so it looks like a lot because I don't have that much space to write everything in a straight line, but on paper where you can write everything in a straight line, I think it won't be that much, and it's easier to see how to integrate that.
Ma'am,
Yeah.
how long is test 2 gonna be?
I don't know yet, but probably the same amount of time as test 1. How long was test 1?
I think was it 1 hour 45 or something. So it's only gonna maybe have 2 questions. Because
No.
these questions are long.
No, this question is no, this question is not long. It's because I'm explaining what I'm doing. No, in the test you won't be explaining anything. In the test you are just writing. You're not explaining anything to anybody, so it won't take long. Why must it take long in the test?
Page and a half.
Is there really a page and a half?
Miss,
I just don't have that much space here. Yeah.
is it open book?
I don't know. I don't think so. Mr. TK hasn't said anything, but I don't think it will be.
Please find out, ma'am, because sure.
Just prepare for a face-to-face test. That's all you must do. I don't know. I haven't spoken to him in a while, but I doubt this will just be an open book. Because with integration, you must know the techniques.
Is it only integration, no differentiation?
It should mostly be integration, but you can see that integration and differentiation are related. So even if the test covers mostly integration, you still have to know some differentiation because they are related, obviously. But yeah, let us do another question, a question from exercise 4.6.4. Which one did I want to do? There was, okay, this one was on, this one was plus, so we find one with minus. Okay, number 3. So number 3, we have to integrate x plus 3 and then square root of x squared plus 2x dx. Okay, so here again, remember we must first split this up into 2 integrals. So the first part you must rewrite this so that it's the derivative of what you have here. So I need 2x plus 2 because that's the derivative of this one. And then the second part we will use our substitution. So if I do that, I want to make this x plus 2x plus 2. So I can first write it as x plus 1 plus 2. So this is the integral of x plus 1 plus 2. and then square root of x squared plus 2x dx. Then I split it. We said this one will be x plus 1 square root of x squared plus 2x, and then plus 2 times the square root of x squared plus 2x dx. Okay, so this is what I have to integrate. So I need a 2 here and a 2 there. So I multiply by 2, and then there's a half outside. So this is the integral of a half 2x plus 2 square root of x squared plus 2x plus 2 square root of x squared plus 2x, and then my dx at the end. So this half will go outside of the integral for this part, and then this 2 will go outside for its own integral. And excuse me, and then this one here, we need to complete the square so that we can see what substitution we're making. So over here, we're looking at 2 integrals. So I have this integral, a half integral of 2x plus 2 square root of x squared plus 2x dx. That's my first question, or the way I'm splitting it. And then the second one is 2 integral of, here we need to complete the square. So I have x squared plus 1, x plus 1 squared rather, and then I have minus 1 outside dx. Okay, so look at it as 2 questions that you're integrating. So let's do the first one. So if you are going to split them in the test, just make sure it's clear what you are doing so that I know what you're doing when I'm marking. So for the first one, here, the integral, very easy to do because I have the function with its derivative. So the answer to this one is just a half. And then I have x squared plus 2x to the power of half plus 1, which is 3 over 2. And then I divide by 3 over 2. And you would put your constant, but remember there's another integral which will also come with its constant, and then you'll add all the constants together. So half divided by 3 over 2 is 1 over 3. So this one is just 1 over 3 x squared plus 2x to the power of 3 over 2. And I'm putting the constant for formalities. Then I look at the second integral, or the second part, which is this one here. And I need to make a substitution. So first, u will be equal to, yeah.
Is it wrong if I just do everything in the same thing, like, because I can see that Miss divided one with the other one?
Yeah. No, that is fine. I just don't have enough space horizontally to do everything in one line. That's why I'm breaking it up like this.
So it looks like it's not that long.
Yeah, well, they won't fit on my page here. That's why. If they could fit, I would do everything in one line. Okay, so here u is this. So this means that du is dx. So I have 2 integral of u squared minus 1 du, and now I make the trigonometric substitution. So this is u squared minus 1. So when we have minus a squared, we have to use sec. So our substitution will say u is equal to 1 sec theta. And this means that du is sec squared theta d theta, sec theta tan theta. Yeah, so sec theta tan theta d theta. Okay, so now integrate. This is the square root to u squared. This is sec squared theta minus 1, and then multiply by sec theta tan theta d theta. Then sec squared theta minus 1 is tan theta. The square root of tan theta, tan squared theta, the square root of tan theta, tan squared theta is tan theta, which we will multiply by this. And we are working out 2 integral of sec theta tan squared theta d theta. And here we must just use by parts. We've integrated this several times already. So let u equal to tan theta. Du is sec squared theta d theta. Dv is sec theta tan theta d theta, and v is sec theta d theta. So remember, this is what we are integrating. So we will have 2 times uv. So sec, there's no dv here, d theta. So 2 sec theta tan theta minus the integral of v du, which is sec cubed theta d theta. Okay, so this is 2 sec theta tan theta, and then this sec cubed theta. Yeah.
Before you go on too far, there at the top of the page, 2 integral sec theta tan squared theta. How did you get tan squared theta? Did you say that the square root of 2, the square root of sec squared theta minus 1 is equal to tan squared theta, or what did you do there?
Sec squared theta minus 1 is tan squared theta. And the square root of tan squared theta is tan theta. So I have tan theta times sec theta times tan theta. That's how I get tan squared theta.
Oh, okay.
So here again, our sec cubed theta, we must write it as sec squared theta times sec theta. So this is 1 plus tan squared theta times sec theta d theta. Okay, so this is sec squared times sec, then the sec squared, I write it like that, then I multiply out, then close the bracket there. Okay, so this is 2 sec theta tan theta minus 2 sec theta d theta minus 2 sec theta tan squared theta d theta. And now you can see that this one here is the same as what we have that side, so we can take it to the other side and then divide by 2. So we have 2, and I keep the 2 here. This is sec theta tan squared theta d theta. This is 2 sec theta tan theta minus the integral of this is 2 ln of sec theta plus tan theta. Okay, and then we can divide everything by 2. And we have the integral of 2 sec theta tan squared theta. This is equal to sec theta tan theta minus ln of sec theta plus tan theta, and then we add our constant of integration. Here, okay, so that is what we have. We have now found this integral that we're looking for. We just need to rewrite it in terms of x. Okay, so doing that, remember the substitution we made. What was the substitution? We said that u is x plus 1 and u is sec theta. So we draw our triangle. So u is sec theta, so this is the hypotenuse over the adjacent, and this is the square root of u squared minus 1. So sec theta in terms of x, this is x plus 1. Then tan theta would be the opposite over the adjacent. So, and then we write it in terms of x. So this is x plus 1 squared minus 1, like that. Now we substitute everywhere here. So sec theta times tan theta. We should now just write the integral. Okay, so the second integral after we split them up, so we have 2 integral of the square root of x plus 1 squared minus 1 dx. This is equal to sec theta times tan theta. Let me see. Okay, so it's just sec theta times tan theta. We have x plus 1 times the square root of x plus 1 squared minus 1. And then the second one was ln of sec theta plus tan theta. So then minus ln of sec theta plus tan theta. And then this one also comes with its constant integration. Okay, so that is what we have for this integral. Then remember, we have to combine those two. So now we can say that the integral of x plus 3 multiplied by x squared plus 2x dx. This is equal to the first integral that we got was 1 over 3 and x squared plus 2x. It had a constant, but that constant will just add it to that one. Then the second integral, which is all of this. So we have x plus 1 times the square root of x plus 1 squared minus 1, and then minus ln x plus 1 plus the square root of x plus 1 squared minus 1. And then we add our constant of integration. And then you are done. Okay, I think we can do,
Hola,
yeah.
ma'am. Hola.
Yeah.
So we are not supposed to put the 3/2 as the first Chandiki integral.
Which 3/2?
The power.
Yes, we should. We should. That was an oversight.
Okay. Yeah.
Okay, then one more. This is number 6. We have the integral of 3x plus 1, and then the square root of 1 plus 2x minus x squared dx. So again, we must split it up. So the first part, the derivative of this multiplied by this fraction by this radical, and then the second part we will use our trigonometric substitutions. So here we want the derivative of this is 2 minus 2x. So this number here has to be a 2, so we can put a 3 here and then minus 2. So we say 3x plus 3 minus 2, 2x minus x squared dx. Okay, and then this is 3x plus 3 square root 1 plus 2x minus x squared, and then minus 2 square root 1 plus 2x minus x squared dx. Okay, then here we say this has to be -2, -2, so we factor out the 3 and then divide by -2. So we have the integral of -3/2, and then we have -2x minus 2 square root of 1 plus 2x minus x squared. That is our first one that we'll integrate. And then the second one is this one, 1 plus 2x minus x squared dx. So if you have enough space on your paper, by all means, write it all horizontally and then solve it. But because I don't have enough space here, I'm just going to integrate this one, integrate that one, and then write my final answer as the combination of the two. So with the first one, we have -3/2 integral of minus 2x minus 2 square root of 1 plus 2x minus x squared, so dx. So we say with this one, because this is the derivative. Oh goodness, what have I done? No, it's not the derivative. Okay, yeah, all right, so the derivative of this is minus 2x plus 2, so I don't need a plus 2 here. So that means the way I took it out here is not correct. So here, this number has to be -3. So this has to be -3. And then this one here has to be, because I still want to end up with 1 here, so it's -3 plus 4. Okay, so this is plus 4. Then this is -3. And then this one will be plus 4. Then I still take out -3 here, and then this one here will now be plus. It's very easy to make a mistake. Okay, so negative 2x plus that. So if we multiply, we get negative 3x, and here we get, no, here we get positive 3x, and over here we get negative 3, which is exactly this. And this is the derivative of that one. It's negative 2x plus 2. Yes, okay, so just
Unless
be
you are
careful.
confusing me.
It was just an error, but nothing has changed in the way that we do it. Said this term here must be the derivative of that one. Okay, so the derivative of this one is negative 2x plus 2, which is what I have here. Okay, and then, like I said, the first one, for space, I have negative 3 over 2 integral of minus 2x plus 2. Then square root of 1 plus 2x minus x squared dx. So remember, with the first one, this term here must be the derivative of that one there. Okay, so getting the derivative there is just algebra. You must find a way to make this term there the derivative of that one. Okay, then we can easily integrate. Since I have a function with its derivative, this will be equal to negative 3 over 2. And then I have 1 plus 2x minus x squared. The power becomes 3 over 2. And then I divide by 3 over 2. And then the 3 over 2's will cancel. And this, you can add your constant, but it's the first part of the derivative. So it's 2x minus x squared to the power of 3 over 2, and then you can put your constant there just for formalities. Okay, then the second one, this one, the one that takes a little bit of time, but not that long, because all the integrals are essentially the same. So you should see the pattern already. So here I have 4, this, so this is what I want to integrate. So to integrate this one, I must complete the square. So I have the 4 outside, and then under my square root, I will have this one, just complete the square. We have 2 minus x minus 1 squared dx. So we'll let u equal to x minus 1. Du is equal to dx, so it's 4 integral square root of 2 minus u squared du. Okay, so now I have a squared minus u squared. So here I must use sine. Yeah, because I'll have 1 minus sine squared, which is cos. Yeah, I must use sine. So here we then let u equal to the square root of 2 sine of u, sine of theta. So this was one of the first trigonometric substitutions that we did. So du is the square root of 2 cos theta d theta. So for the integral of the square root of 2 minus u squared, this is 2 cos squared theta. And then du, this is the square root of 2 cos theta d theta. This is 4. And then 2, then 1 minus cos squared of theta. That will be sine squared theta. Then we have sine theta cos theta. Okay. Going very fast, that's why. So this is sine squared theta because it's this one squared. Okay, so then I have 1 minus sine squared theta. The square root of that is just cos theta. This theta is cos squared theta d theta. Okay, this is 8 integral of cos squared theta d theta, and we said to integrate cos squared theta, we rewrite it as a half 1 plus cos 2 theta. So this is 8 half 1 plus cos 2 theta d theta. Then the half and the 8 will cancel, so I have 4 integral of 1 plus cos 2 theta d theta, and this is 4 theta plus the 4, and then I have sine 2 theta divided by 2, and then my constant of integration. Okay, those can cancel. This is 4 theta plus 2 sine 2 theta plus c. Now we need to remember our substitution. So we said u is x minus 1 and u is the square root of 2 sine theta. And u is the square root of 2 sine theta. So sine theta here is u over the square root of 2. And remember that sine 2 theta is 2 sine theta cos theta. So this here is 4 theta plus 4 sine theta cos theta plus my constant. Okay, so continuing with what I substituted, this means that theta is sine inverse of u over the square root of 2, which is just x minus 1 over the square root of 2. And then cos theta, we need our triangle. This is theta here. This is u over 2, that's the opposite. That's x minus 1 over the hypotenuse. And this side here will be the hypotenuse. This is 2 minus x minus 1 squared. Okay, so that means that cos theta is the square root of 2 minus x minus 1 squared. Ooh, sorry. Okay, it's back now. We're almost done. Okay, and cos theta is the adjacent over the hypotenuse, and because they're both square root, then you can include them under the square root or it'll cancel with this one here. Now we substitute. This is 4 theta. Theta is sine inverse of x minus 1 over the square root of 2, and then 4 times cos theta, sine theta first, which is x minus 1 over the square root of 2, and then cos theta, square root of 2 minus x minus 1 squared over the square root of 2 plus my constant. So you can see this times this is 2, so you'll have a 2 here in the numerator, and yeah, that will be that. So just, yeah.
It's a triangle. Is it the adjacent, is it x minus 1 squared? The square root of x minus
This
1
is
squared,
2.
or is it 2?
It's 2 because it's the hypotenuse squared.
Okay. This is like x.
Okay, I think from here you can then rewrite the two integrals together because I have another class now. Okay, so here the only thing I can say is the integrals or the substitution that we do are all pretty much the same. There isn't anything that you're integrating. You'll either integrate cos 2 theta or sec cubed theta or sec theta tan squared theta. That is always what happens. But go and practice. There's 4 other questions in the exercise, so try those ones and we'll continue tomorrow.